Okay, so thank you very much, everyone, for joining us. This is going to be a webinar presenting our SurCoNew concrete admixture. If the way I'm going to go through this exercise, it's a very brief presentation. We'll kind of explain who we are, where we can help with this new product, and also at the end there's going to be room for question and answers. We have Bob Walde and Anthony Fiasco, who are the founders of Surtreat and the inventors of the technology. So I think we're going to be able to have a very good Q&A at the end. So without further ado, I'll start by introducing Surtreat Solutions. So what we are a technology-based company, and our main focus is to provide turnkey technical solutions to strengthen, protect, and restore structural elements. Now, our approach is not like a traditional materials company. We focus on the chemistry of the concrete and the chemistry of concrete deterioration. And we do this with surface applied solutions. As our name states, Surtreat, it's a surface treatment. And to summarize, what we do is create life extension technology for concrete. Now, our story begins in 1989 when we're founded, and we start working with develop our technology, and we start working with institutions like the Department of Energy, like NASA, and like the Army Corps of Engineers. This was mainly to put our technology into the right hands so that it could be used in a wide spectrum of projects. With FERMCO, we worked on, or with the Department of Energy, we worked on a FERMCO nuclear plant to extract nuclear waste contaminants from a warehouse facility. With NASA, we worked with the launch pad 39A to make sure that the corrosion wasn't deteriorating the launch pad. And then that opened the door for us to start working with the Army Corps of Engineers and in the process to get certified as a corrosion inhibitor for military facilities. And that's where a 10-year study with them started, where they were going to prove the efficiency of our three-part system over a period of 10 years. In the meantime, we worked with the New Jersey DOT and we are the product that's specified in their bridge preventive maintenance program since 2010. We expanded our horizons internationally, and we started working with the EU and get certified in the EU. And then in 2016, after that 10-year study, Surtreat, the three-part system, was included in the Unified Facilities Guide specification, which is the specification or the guidebook for pretty much all the military facilities around the world, and including other agencies like the GSA, like NASA, like the Department of Energy, State Department, and Homeland Security. So anywhere in any of those facilities that there's corrosion, our system is able to is already approved to work in any of those environments. And then in 2019, one of our latest achievements was to, with the help of our founder, Bob Walde, develop the Surface Applied Corrosion Inhibitor Guideline. Currently, our three-part system, is the only system that meets all the criteria in that guideline. So, started in 1989 with a technology, with an idea, and we've come all this way in working with NASA, the Department of Energy, with New Jersey DOT, with NAVFAG, with Department of Defense, working abroad, and with institutions like ICRI. So just to add a little context of what our technology has been able to do over the years, our technology will benefit your bottom line significantly because of the surface applied nature and the chemical nature of our products. There's minimal concrete removal and replacement. it's a significantly less labor intensive. It's a permanent solution, it's a chemistry solution, so it's only a one-time application. You don't have to reapply after 10 years. It doesn't wear out. So far, over our 30-year history, we've never had anyone come back and say, hey, your product or your solution didn't work. So up to this point, we've had indefinite extended service life. All the structures that we've treated have continued to be healthy and continue to operate without any disruption. Our non-destructive application allows for continued operation of structure, which is one of the main things that the New Jersey DOT liked about our systems. You don't have to close the whole bridge. We can work at night, close half a lane, and install our solution with minimum disruption. And it's a fraction of the cost than the alternative solution. Over the years on all these projects, we've been able to provide savings from 60 to 80% based on the engineered solution that was initially prescribed. So significantly cheaper, and this is how we benefit your bottom line. Now, our difference, we're not in selling products. We want to make sure that what we're doing in your structure has a quality, and it's gonna have an indefinite extension of service life. So what we do is we go to your structure, we determine what the problem is through diagnosis. With that information, we design the solution that's specifically suited for your structure. We manufacture that solution. We provide the on-site inspection and the training. And we also do, after the installation, we also do post-testing and monitoring. And the result of this is healthy concrete. So this is what we're going for, healthy concrete. Now, let's start with some of the basics. So as you all know, corrosion of reinforcing steel is the leading cause of deterioration in concrete. Concrete is a living structure. It's a chemical process that results in that material that we see that's cured as a solid block of concrete. Now, reinforced concrete also, you add that extra, I guess, compound that's steel. Now, steel will deteriorate through corrosion. What happens is that corrosion, and I'll explain in the next slide, but the corrosion will start to create tensile stress, they'll laminate the concrete, and that's what we see as falling or cracking. Now, concrete that has been deteriorated because of corrosion will definitely result in increased maintenance cost and time-consuming repairs. Because of the nature of corrosion, it doesn't stay in one spot, it migrates to the rebar, and you might have a spall here, a spall there. So the bottom line is, if corrosion is present in the rebar, in the concrete is compromised. Now, how does our technology work? Again, as I was mentioning, concrete is almost like a living organism, and it's very porous. 20 to 30% of the cement phase is the porosity. So over time, contaminants, oxygen, moisture, chlorides start penetrating the concrete through those gel pores and through the micro cracks. As those contaminants are penetrating into the concrete, the pH of the concrete starts decreasing. So usually when concrete is new, you'll have it at 11 or 12, sometimes even 13 in the pH scale. And that creates a passivating film around the rebar, which doesn't allow corrosion to happen. Now, if we were in a controlled environment and nothing ever changed, it would last forever. However, because of the exposure of those contaminants, that pH starts dropping and dropping and dropping. And eventually, it gets to the point where it drops to a corrosion active state. That's where the corrosion starts infiltrating the rebar, starts expanding, and eventually will delaminate the concrete. Now, what our system does is it migrates to the concrete through those pores, through those gel pores and cracks, regenerate the pH of the concrete. Anywhere that there's already corrosion, it will convert it into an inert shell, so it hardens the rust, so it doesn't keep expanding. As the pH increases, the corrosion passive state will start to regenerate again in the concrete, preventing that corrosion from happening again. Once that process is is done, our compounds are also bonding with the free calcium that's in the concrete, generating new concrete and sealing those micro cracks and those gel pores. So it's decreasing the permeability of the concrete and the porosity of the concrete, and doesn't allow those chemicals to damage the or lower the pH of the concrete again and returning it to a corrosion active state. Now, just to put it into perspective, you might say, well, if I put new concrete, if I'm patching something, I put new concrete, I'm putting that high pH concrete again. And you're right. But because of the cathodic and anodic process of the current, the corrosion current and the cathodic and anodic process, that concrete that's that concrete that's deteriorated and has chlorides and has a low pH it's eventually going to accelerate the corrosion in areas that are adjacent to the patch and even in the patch itself. So you might patch one area and then it's going to travel down the rebar and then you're going to see a patch spall in a different area. So, and also, you know, there's another problem, which is the environmental aspect. Every time we're patching, we're generating new concrete, and that concrete, the creation of concrete, is approximately the 8% of global CO2 emissions that are directly attributed to the production of concrete. That's about 4 billion tons annually. If we put it into a perspective of like a country perspective, cement production, concrete production is the third largest polluter or CO2 emissions polluter after China and the United States. So it's a significant impact to the environment that creating new concrete does. That's also not to mention the major water pollution, the dust that's generated, and the mining of ground assets. So there's also another aspect. Once we remove all that concrete, we have to put it somewhere. And so all that waste that's generated, demolition represents more than 90% of the total concrete and concrete debris generation. So, so that is that's again another significant environmental impact that having new concrete has. So what can we do? And this is where our Surtreat solution comes into play. So we have SurCoNew. SurCoNew it's our proprietary organic vapor phase migratory corrosion inhibitor. That's as I mentioned, the UFGS 3-part system has a vapor phase migratory corrosion inhibitor that basically migrates as a vapor and prevents the corrosion and prevents any corrosion that's already in the rebar, turns it into an inert shell and regenerates that passivating layer. Now what we've done is designed it to be used as an admixture for reinforced concrete. Instead of going after the concrete is cured or after you start seeing issues, you can prevent that issue from the get-go. So some of the benefits of SurCoNew are that, unlike calcium nitrate, we are a permanent fix. Like, we don't get consumed by the concrete and the curing process, and it will not harm the concrete. As you know, if you start adding a significant amount of calcium nitrate, it can have a negative impact on the concrete. We are also added in comparatively small quantities. It's about 1/4 of the product per cubic yard. We're also, because of the nature of the product, we are particularly effective on any concrete that's exposed to like a high chloride or aggressive chloride environment. One of those, any property that's on the beach, any property where you might be adding salt or mag chloride to prevent any snow or any ice from generating in the surface, and you know, anywhere where you're going to have salt exposure or chloride exposure. And it is also very compatible with other additives. So if you're using any additive like a water reducer, an accelerating, a retarding admixture, a super plasticizer, our product will not have any negative effect with that, because it's, again, the job is to migrate to the rebar and protect the rebar. Now, how does it work? as I mentioned, concrete is very porous, and through those pores, a lot of things migrate, right? Surtreat, SurCoNew, migrates through those pores in vapor form and deposits on the rebar surface, where it gives that corrosion protection. Why is it important to do it when concrete is new? Because as you can see on the picture to the right, the rebar will not always be corrosion-free when it gets to the site. Sometimes you're going to have spots where there's already corrosion starting, and if you let it sit there, it's just going to propagate. So if you want to do this when you're recently installing, to avoid those future maintenance costs and those future repairs and time consuming that generates. Now, we're saying all this and it sounds great, but how do we verify that that's what our product does? Well, over the years, again, as part of testing our technology and making sure that it does what we're saying it does, we've done significant testing. One of them is with the Alpha TAM group that I'll explain the experiment in a little bit more depth, but we comply with the performance requirements of ASTM C1582 and G109, which is usually what you guys are going to see in the specification whenever there's any concrete corrosion inhibitor, concrete admixture. They're going to be looking for ASTM C1582 that it complies with that, and we do. And also through those testing procedures, we verified that it doesn't have any impact on the concrete curing process. So we're not, if in the specification it says something about like it has a curing performance, we're not going to be affected. We're not going to be affecting that performance. So I'll go ahead and explain the Alpha TAM group testing. So Alpha TAM is a conglomerate in the Middle East, is one of the largest construction manufacturing conglomerates in that area. And what they did, and it all starts with like a little story when we started going internationally, how they wanted their cities to last 100 years, and that's a really good mentality, because that's what we want as well. As Surtreat, we want the infrastructure to be there for our grandkids to enjoy, and it still be healthy. So they started with that notion of how can we extend the service life of structures. We presented our product, they liked it, but they obviously had to prove the performance. So we set up on a course of testing it for 1 year. They created 6 blocks, 3 were untreated, and the other 3 were treated. Those were exposed to a solution of sodium chloride. The control, and over the testing was like 2 weeks exposed to the environment, then 2 weeks off, then 2 weeks on, for like that over the course of a year. Now, after the year, and they started doing the monitoring, they saw that the control blocks gave a current measure of 10 microamps. So effectively, that was already giving a very detectable corrosion current, while the treated blocks, which have the inhibitor, the SurCoNew, were giving a reading of 0 microamps. So effectively, after 1 year, the SurCoNew treated concrete gave no detectable corrosion current. To them, that was proof enough that the system worked, and it's been in use ever since. The test was performed in 2006, and ever since we've been used there as a corrosion inhibitor admixture. Now, we also performed tests here at home, where we were looking that because of the type of chemistry and the reaction that was occurring, that the changes in the concrete were likely improving the wetting process, and that improved the compressive strength of the shotcrete mix, and it also improved the resistance to chloride penetration. So it bonded with the free calcium, and it reduced the porosity, which gave it a resistance to the freeze-thaw cycle damages and to those chloride penetrations. 2 tests were performed independently. One was with the Robert B. Walde company, and the other one was by Aldea Services. And in both we can see that there was an increase in PSI of about over 1,000 PSI, and an increase in flexural strength of about 60 psi. So that's a very significant increase for something that takes almost no time to install. You just add it to the mix and you pour it, like you normally would. So the benefit that that's bringing to your structure, to your construction, to your customers is going to be noticeable 10, 15, 20 years from now. Just to summarize, as we went through the presentation, we saw that the main cause of concrete deterioration is corrosion of the reinforcement. We saw that prevention of that corrosion will save time and money in repair and maintenance. As we use less concrete, we'll reduce the contribution of total global CO2 emissions. Obviously, not the whole 8%, but everything we do counts. We will also prolong the life of an existing concrete structure or a new concrete structure without demolition. If it's a new concrete structure, of course, you're just going to prolong the life of that structure. But if you're dealing with, let's say you have to patch certain areas, you are going to prolong the life of that concrete structure without taking out the damage that's eventually going to occur. And the utilization of our technologies will extend the service life of your structure. And our technology is a proven technology that's ready to be implemented. All we need, we have the specification ready. We have the technical data sheets, the material ready. All we need is to put it in the project and enjoy the benefits. And just to kind of close out with the message of what Surtreat is and what we're trying to achieve. We're trying to be an enduring solution. We're trying to be an effective solution, an efficient solution. We are environmental and we are an economical solution. So those are the 5 E's where we think we can affect change, and we're here to help you in any way we can. So with that, I open the floor for any questions. I have Anthony Fiasco and Robert Walde from the technical department to answer any technical questions.
Hey, Guillermo, Mario. What does this take the place of? Which TPS 2 or 15 or what is that? Or are they still available?
This is a new solution that's SurCoNew, so it's an admixture. But if you want to equivalize it to something, it would be similar to the 15.
All right, so you would eliminate the 15 in lieu of this? Is that the way it works? I'm not sure what the process would be.
Sure.
Okay. What about the cost per quart? What does that apply to? What's the cost per quart per cubic foot for the application?
We have different pricing methods. One, for example, if it's for a large project, if it's for a residential, so it would have to be project by project basis. But overall, it doesn't add more than $20-25 per cubic yard.
All right. Thank you.
Does anyone have any questions about how the technology works and or some of the utilizations that can be where we can have some impact?
Well, most likely, if we approach a particular engineering company or a contractor, we probably may need some of your help. Since you're the expert on this whole thing, I really appreciate that. Yeah. I think it's very exciting technology. I think it's going to help us probably add more to our sales base, and I'm looking forward to promoting it.
Thank you. We appreciate that. Bob, is there anything you want to add on the technical side that I may have missed?
Well, no, it was excellent presentation, Guillermo. Just to add, the present product that's been specified for probably 25 years now is calcium nitrite. It comes out under various trade names. Just about everybody who is in the sale of concrete admixtures has it on their catalog. The problem with it is it's consumed in the corrosion inhibiting process. And it has detrimental impact on the physical properties of the concrete. That's the whole purpose of 1562, is to verify that the amount that's being added is sufficient to give corrosion inhibiting factor over a period of 150 coulombs. The coulomb is measured by the corrosion current with respect to time. Most calcium nitrite that's put in at a level that it has minimum physical impact dies at about that point in time. When we extrapolated the testing that was done in El Shatumi out to 2 years, at the end of 2 years, our system was continuing to inhibit and produce no corrosion current. And contrary to reduction of physical properties that calcium nitrate does, we improve the physical properties. You have to realize that what the competition is and how it's specified. Unfortunately, many of the specifications for calcium nitrate are not written on a performance basis, but on a chemical composition basis, which of course excludes our particular chemical formula. But I do believe everybody now is incorporating, must be in compliance with Surtreat, with ASTM 1562. And once they do that, then you need to, in that specification, produce data that shows that you have no impact on physical properties and that the product at the end of 2 years of high current is still functioning. That's the key thing. We have a white paper on that, which if you don't have a copy, I know Guillermo will see that you will receive one. And we probably do have that also mentioned and specified in the technical data sheet for the SurCoNew admixture inhibitor, where we've upgraded. We're now designing our technical data sheets to target the specific details of specifying for the end use, as opposed to sometimes we were writing the technical data sheets on a more broad spectrum chemical basis.
Absolutely. We'll make sure that everyone in this presentation has the package, complete package with the technical data sheet, the testing reports, the specification, and this presentation included as well. But well, if anyone has any other questions or any other comments, please make sure to either let us know or email us. Would like to hear from you, go to our website, surtreat.com. It has a lot of information, not only on this solution, but on our other solutions and the other things that we can do for your structures.
Guillermo, Mario again. One more question. I'm assuming that this is basically if we convince the engineering company designing for a contractor that this would be to apply this because of its longevity, because it straightens, it's a much better product. It makes the concrete much more stronger, lasting longer. So I assume we can approach either the engineering company, a contractor, concrete contractor, or the individual company that's going to be asking an engineering company to design something for them. So we have three areas of discussion, I would think. Does that make sense?
I would add one more. I think the engineer is key, because the person designing the specification is the one that's going to be able to increase the performance of the current admixture, which is calcium nitrate. And obviously we have more benefits and we have a better performance than calcium nitrate. So that's the clearest one. The contractors as well is a really good one, because if they're installing something for for a client and they don't want to be called back and have to do a recall or repair something in 5 years because of some corrosion damage, that's another one. I would also add precast concrete manufacturers, because we can, again, they're the ones making this precast concrete pieces. So for us to be able to go in there and give them that extension of life from the get-go while they're doing them, that's also a great benefit. That's gonna make their structures last much longer. And another one that I think would be a really good start for that is not only the engineers but the owners, making them aware that there is something that's, while they're doing something new, that they can have that impact, that extension of life. I think that's a good 4-prong approach.
One more question. If on old concretes like sidewalks or curbs, would this be applicable, similar to 2PS2 or not?
That would be our SurCoRepair, our 3-part system, where you would have the best performance. However, if there is going to be installation of new concrete, you can add the admixture. So if a sidewalk, like you were saying, is scheduled for repair and they need to put a new piece in, they're going to do new concrete, you could use the admixture. But if it's already in place concrete that's cured, our SurCoRepair 3-part system would be the best way to go.
So you're saying that, so you can apply SurCoNew to old concrete curbs and sidewalks and have the same effect as it maybe a TPS2 for longevity and increasing pH?
Not to existing concrete, but to new concrete. So
only new. Okay.
Yeah,
so we don't want to apply to old concrete, you're saying?
No.
Thank you.
Absolutely.
Mario, just to
Yes,
get
hi, Bob.
some time ago, I communicated with the Illinois DOT about our admixture. And at that time, I discovered that their specification for concrete corrosion inhibiting admixtures is based on the chemical description of calcium nitrite. So I sent my whole data package in, and it dealt with a young lady there. And the response I got back was, well, yes, we see your product and we recognize it works, it's good, but it doesn't meet our spec. And I said, well, yeah, I realize that because the way it's written, then, but you should probably, why don't you amend the specification to allow others to be included? Well, they didn't want to do it, because it would take a little extra effort on somebody's part to do that. But that was before ASTM 1582 was published. And with that, that's what gives us the leverage to try to get these DOTs who like to sit on the past to get off the past and start bringing in, modifying their specifications for the more advanced technologies. So if you go to them, you'll know that background.
Okay. Bob, we're working with a former representative of Illinois who has raised funding for IDOT here in Illinois and the various Metro and CTA. So we're working with him because he knows where the decision makers are. So if we could approach, I'm not sure who you spoke to at IDOT, but you could maybe give us that information. We can follow that up.
Yes, Tony has the files. Tony, will you go and look at the files on Illinois and send Mario the communications that we had back then?
Yes, I will.
Thank you. We'll follow up with it, Bob. Again, thank you very much, Harold.
Well, thank you very much for joining us today. And again, please, if you have any questions, make sure to email us and visit our website, surtreat.com.
I just have two things that I might want to add to expand on what you had presented. When the new concrete, we come in with the pH of 13, and that creates a corrosion passive film on the rebar. When it drops to 11, it goes into a corrosion active state. And the damage is caused by the fact that the rust that's being formed occupies 6 times the volume of steel. So it's the expanding rust that puts pressure on the concrete, causing delamination first, then spalling. And with green rebar, we get a response back. People say, well, we're using green rebar now, and it doesn't really have any negative impact. Well, the problem is, of course, the green rebar coating, which is epoxy paint, is protecting it from the concrete. And what we've found is that where you get damage on the rebar, you create a cathodic site. You can actually have corrosion right underneath the coating of the rebar corroding. So those were a couple of things just to add. That one picture that you did see was of green rebar. And what we're really talking about is where they're using regular steel. Now, when you put in the green rebar, you reduce the bond between the rebar and the concrete. And it's that bond strength that is critical to forming this monolithic combination of steel and concrete. Steel strong in tension, but weak in compression. Concrete strong in compression, but weak in tension. But the bond, you must have a strong bond between the two to get that monolithic effect on overall strength. So the specification for the green bar is you have to put in 30% more. Or if you use regular rebar, you can reduce the amount of steel. And then the cost of the inhibitor is far less than the elevated cost of the green rebar. Increase, plus its increased price, we're putting the coating on it. And then the care which must be taken such not to damage it during installation. So that's our story around the green rebar. Yes, the green rebar does inhibit contact with air, water, and chlorides, but it also inhibits contact with the high alkaline cement. And you require 30% more of more expensive rebar in construction. We're using regular steel. You don't have to increase it. It costs less. And the added cost of putting in a quart or two per cubic yard of our admixture is significantly less than the elevated cost of the additional costly rebar.
Interesting.
So that's something to get integrated. You might want to try to figure out how you might put that into the presentation, Guillermo, because that's what we're competing against. We're competing against green rebar for new construction, and it's only new construction for anybody's going to put in an admixture. And we're competing against calcium nitride that's embedded in all the specifications, not on a performance basis, but on a chemical composition basis.
Hey, Guillermo, would that be a separate webinar? I mean, a separate PowerPoint? That's a very interesting information that Bob brought up. Very compelling. I mean, it adds a lot of credence to what we're doing with Surtreat with either the engineer or the client or the contractor.
Yeah, absolutely.
Yeah, well, what Grandma put together is an overview, and what I've just talked about is where you dig in now to the fine details, and you can dig even further beyond what I just said. So this is where we get into where people are out there who are acting as our agents, selling to various organizations. That's what you're going to run into. Well, when you do run into that, say, yes, we have an answer to that, and we can tell you how you're better off using our product than using calcium nitride or the green rebar.
Yeah, and also as a reminder, we what we're trying to do is a turnkey solution. So if once the project comes in that there's going to be a need for the corrosion inhibitor admixture, we can take a look at the whole project and say, hey, we can save you money here, we can save you money here, we can save you money here. So this is where a technical department shines, where we can find those inefficiencies and just provide an alternative solution that's going to significantly reduce the cost of the project.
Hey, Guillermo, we're having a webinar on the 5th with IDOT. So I'm thinking what Bob has brought up could be very compelling to list that. And then I'm not sure what slides we're going to show, but I think what you presented today was excellent. Great job, by the way. And what Bob brought up, I think, is also very compelling. We can present that because they're building roads all the time here in Illinois. They're adding about another 50 miles on our tollway.
No, absolutely.
So
you and I can talk offline.
Okay, thank you.
Yeah.
I'm sorry to.
Yeah.
Okay, thanks.
Absolutely, no worries. Yeah, I don't want to take anyone else more of anyone else's time. So again, thank you very much for joining us today. And if there's anything that we can do for you, just contact us, and we'll make sure to service your needs.
Thank you. Good job, Guillermo.
Thank you.
Great job.
Yeah, thank you, Guillermo.